All right, guys, here's our last segment of our 2D kinematic notes. These ones are talking about symmetry, and they're going to be real quick. So you can see above that we have a picture of a projectile being launched, and we can see that there's the launch point A, and then the apex B, and then again when it reaches the initial height that it was launched at C. So what do we already know about this? So what is happening to the ball as it travels up to the apex? So from A to B, what's happening? So we know that it's being launched at an initial velocity of 5 meters per second at an angle of 30 degrees. Therefore, we can figure out the Vy by taking that total velocity and multiplying it by sine of 30. We get 4. Then we can figure out the Vx by taking the total velocity and multiplying it by cosine of 30, which gives us 3. Now that we know our initial information for point A, let's talk about what happens as it travels to point B. Well, the x direction velocity is constant, and we know that it's remaining the same the entire time because there's no acceleration in the x direction, where the y direction velocity is slowing down, meaning that it's getting smaller or closer to 0, and that's because of gravity. Since gravity is acting in the opposite direction, it's going to slow the object down in the y direction. It's going to slow it down so much that once it reaches the apex, the y velocity is actually going to be 0. Now let's take a look at what happens as that ball travels down from the apex to point C. Well, as the ball travels down, the x direction velocity is still constant, it's still remaining the same, and again, that's because there's no acceleration in the x direction, so that velocity will always be the same. For the y velocity though, at the apex, the ball is stopped or at rest in the y direction, meaning that the y velocity is 0 at the apex, but as it falls, it's going to speed up because gravity and the direction the ball is moving are both in the same direction. Since they're in the same direction, it's going to speed that ball up in the y direction. Therefore, the y velocity is going to increase as that ball falls down from B to C. The total velocity at point C is still 5 meters per second. The x velocity at point C is still 3 meters per second. And now the y velocity at point C is negative 4 meters per second. So you'll notice that all these velocities are almost exactly the same. And that's the beauty of physics, is that there's symmetry in projectile motion. So whatever velocity we launch an object at, that's the same velocity it's coming back down at. 5 meters per second at 30 degrees, and we see it's 5 meters per second coming back down. Vx is 3, Vx final is 3. Initial y velocity is 4, and the final y velocity is negative 4. And it's negative 4 because it's going down now. Let's now talk about what's happening at that apex, or point B. Well, at point B, the x direction velocity is still constant, meaning that it's remaining the same the entire time that projectile is in the air in the x direction. The y direction velocity, though, is 0, because there is no y velocity at the apex. At the apex, the ball is not moving up or down, it's only moving to the right, therefore there's no y velocity. And then, like we said, that x velocity is just the same, it's 3 meters per second, which is the same everywhere because there's no acceleration in the x direction, meaning that the x velocity is remaining the same. So what do we know about the time from A to B to B to C? Well, A to B and B to C will take the exact same amount of time. They'll be equal to each other. And the reason they're equal is because, like we said before, symmetry. However long it takes that ball to go up to the apex, it's going to take the same amount of time for that ball to come down from the apex. So let's say that the time it takes from A to B is 2 seconds. Therefore, the time it would take that cannonball to fall from B to C would also be 2 seconds because of the symmetry in this problem. So let's take a look at one last thing, and this one's going to talk about the distance from A to B and the distance from B to C. So we know the time from A to B is the same as the time from B to C. The distances are also going to be the same. However much distance that ball covers from A to B is going to be the same distance that ball covers from B to C. So let's say this distance is 10 meters in the x direction from A to B. From B to C, it's also going to be 10 meters in the x direction. Let's say in the y direction that it was like 5 meters tall. It would be 5 meters from B to C as well. So what do we know about the angles at A versus C? Well, those angles are going to be equal but opposite. So over here, we're initially launched at a 30-degree angle because we're launched upward. But over here, when we come down, our ball is pointed downward, so the angle is going to be negative 30 degrees. And the negative just means that we are pointed down. So basically, A to B, up to the apex, is a mirror image of B to C from down to the apex. This is very useful and very helpful when trying to solve those angled kinematic problems.